Everyone, because he built, the owner didn't want to build, it's expensive to build a farm, but he's making products that he's selling, and the piece of land is actually cheaper than other agricultural land. And so suddenly the heating bill in the winter went down, because there's now a thick layer of insulation on the roof, and then the bill for air conditioning in summer went down because the roof is not black anymore, and suddenly everyone is happy, right? And so I think there's another question coming that I should keep that for later, but it's all about, because they showed us a question.
Well, this is the next one though.
Oh yeah, because I do the 3 questions in a row.
So
okay,
how can district energy systems be used to create communities?
I'm
glad
you asked. So in the end, the problem with the way we do things is we don't have time to think. We get rushed into doing things, and we're on a tight budget, and in the end we do stupid things. And district energy is trying to solve the energy problem on the heating side of your building. So most of us a lot of us use electricity to heat, but actually we see a lot of people use natural gas. And district energy is saying, before you do anything, look at who your neighbors are and talk to them. And let's see if there's anyone in your neighborhood that has extra heat when you need it, and vice versa. And you create a connection between the buildings using basically small underground pipes that are sending hot water from buildings to buildings. And if there's someone that at a given point of time has too much heat and I need it before I buy natural gas or before I start my electric door, it's not like I'm going to call in and say, what about your heat? But it's all automated, of course. But you can now have exchange between buildings, and so that I don't have to vent the extra heat that I have, I can give it to someone else who needs it. And it's kind of hard to imagine in a pure residential context if you kind of all need heat at the same time. But when it's a mixed-use environment, it's surprising how people create excess heat when you need it and vice versa. And so district energy is, and you guys have that in North Vancouver through the Lonsdale Corporation, but it could be expanded in a much greater way, in my opinion. District energy is about being smart and planning and thinking about how you do things, and that would fit with the discussion we've been having about how all these pieces fit together. Yeah, there's a lot of cool things that can be done at the demand side, even though it's not super sexy per se. But yeah, and it's not that complicated. It's just it needs people to talk to each other, and it needs some planning.
So perhaps that's something that would be suitable down at Lot 5 when we're building from the ground up.
I was just going to say
most likely.
We have this opportunity now, and that like I said earlier, it's kind of like a blank slate down there, and that we have Lot 5, but then there's also Lot 4 right next to it. There's the presentation house gallery, which is planned for a little bit further up, and they still really don't know. I mean, the council has some ideas about who they want to participate in all of this down there, but they don't really know what that's going to look like. There's Capilano University is being involved in the conversation. They want to put a site. So right now, before it gets built, is there an opportunity? Like, do you think? Can you design it such that Cap U is situated next to the museum and archives in such a way that they're feeding off each other's energy and using downtime, and like to really design that whole area.
Yeah, totally. Giving
consideration to what you're talking about.
Yeah, totally. So it's just a matter of planning and deciding what kind of mixed use you want. And it could be surprising, the kind of mixed use you want. You might end up thinking a neighbor you didn't really want originally is a good neighbor now because it's good fit with the rest of us. So it gets you to really make. But the challenge, I'm kind of reluctant saying that because there's a camera, but the challenge is us, it's the people. Like it's to get smart people in a room to talk and work together. It's not an easy thing to do. And especially the smarter they get, it sounds like we try to do that. We've built an amazing building at BCIT that we've completed a year ago, and we won some awards for some of the stuff we do. And we're doing a bit of that locally. We're taking excess heat from the other building on the side, and we have a geosync system, so we're actually, when nobody needs anything, we're storing our heat in the ground, and we're keeping it there for a while and getting it out. And so what happened there is amazing, but it was one little team that did this. But then without going into details, we did some other really weird stuff because we're not talking to each other. So when I give tour of the buildings, I'm like, I always have a smart person in the group who says, well, how about, if you're so smart, how about this? And I wish I had a red button and a trap that opens. But I don't have an answer. The answer is we didn't talk to each other. There was a group who was, had an ego that was a bit stronger, and suddenly we made mistakes, and I don't know how you solve the people aspect of planning.
Right.
And I wish someone knew, but it's hard to work at
Let
that
us know if you
together.
figure that out, because.
Yeah. Just bring food.
Yeah, and wine would help.
So Alex, that's kind of interesting, because the next question is about how the incorporation of energy efficient and environmental design could provide opportunities for learning on Lot 5.
Yeah.
So what sort of things?
Well, everything, like Energy 101. I think that I think that people, when they know, if you build something like this, people will take pride in it and talk about it and bring people there to show what's happening, and you don't have to be a geek to it's a form of art, actually. Like you can give a tour of a mechanical room and get people to want to see more, but it has to be inspiring and smart. Right?
So what sort of, and I'm just wondering on the comment you made earlier about how in Greece the houses were all white.
Yeah.
So we're in Vancouver, that white sun reflecting around,
Yeah.
very different here.
Yeah.
So what sorts of things do you think could be incorporated here in Vancouver?
Well, so a few things from a food perspective. You can manage your water locally, so it's not necessarily an energy piece, but water is as important as energy. So you can do a lot of rainwater harvesting, and you can build your system where you use gravity to be able to distribute your water later when you need it without needing a pump that is actually using energy. So the water piece here is big, so we could do our designs having that in mind. But even from a heating and cooling point of view, even though it's kind of very for a few weeks, few days, few months, the sun is still there, and if you orient your buildings the right way, you have the windows on the bigger windows on the right side of the building, and you take advantage of the wind to do some of the cooling, and you take advantage of the sun to do some of the heating. You can do the same thing here, and yeah, you can still build designs your buildings so that they are almost self-sufficient in ways. Yeah.
We have a mild climate, so I could foresee that. It sounds very reasonable.
Yeah, and it's a tough,
Sounds
but
neat.
it's a tough call. You need to think about how you want to do things, right? The towers that we have, like the big condo towers, are not very energy efficient, because we also like windows and we like to have great views, and so you have to think about it's a tough call. It's difficult, but you measure the quality of your installation using something called an R value, and the lower it is, the worse it is. And the R value, the average R value of the new buildings is not that good. Even though we're mild, we have to heat more our space in the winter than we would if we had a wall instead of a window, right? So it's a mild climate, so we're lucky, but it's still cold enough in the winter that we need to heat the inside, and it's still warm enough in the summer that in some buildings, because of all the computers and all the people working in the building, you still need air conditioning. And you just have to decide how you want to design your buildings.
On what's important.
And what's important. And
Yeah.
there are going to be trade-offs, like there's no perfect solution. And maybe one day there's even going to be a silver bullet solution. There's a lot of people doing lots of research in the world right now for this on the supply side of energy. So maybe one day we're all going to be good, and it's going to be nice, but for now, the next 20 years anyway, we have to think about what's important.
So you may have already answered this, but there may be other things that you have to add for how can projects that are underway at BCIT currently in the fields of renewable energy or demand side management apply to Lot 5?
Well, I think I probably already answered this, but yeah, I talked about a bit about demand side and district energy, but really what we're saying at BCIT is look at who you are and try to build on your strengths. And of course find solutions for your weaknesses, but don't think too big. Look at who you are and do what you can do. So one of our neighbor is a laundry facility that has way too much heat in the form of hot water. So we're talking to him saying, well, would you mind if we use some of your heat? We teach carpentry and joinery, so we have 250,000 kilograms of wood waste that we have nothing to do with. That we pay a company $20,000 per year to come with a diesel truck and send to the landfill, and we're saying, well, wait a second, maybe we have a bit of heat here, and we have server rooms that are generating a lot of heat because we have so many computers. We have 4,000 computers in campus just in the labs, and so, and well, you know, if we could, so. If we were one step smarter and one step more organized, we could integrate all these things and yeah, and even use some of our CO2 emissions to grow vegetables, and there's so much that can be done. It's just, yeah.
What a great resource. So before I move on to Tyler's section, does anyone have any specific questions for Alex to build on what?
Ben, do you know how much the Lonsdale Energy Corporation plays into Lot 5?
I don't think there's been, well, I don't.
Gary talked about it, but I couldn't.
So there is a boiler. So Lonsdale Energy Corporation, they have different boilers around the community. And actually, I believe out here there's some stacks. And I believe this is a boiler, like right out here. So there's another similar boiler down at Lot 5, which provides steam to the buildings close to there, and ideally Lot 5 in the future, depending on what goes there.
But and it's got the ability to go under the building and everything and do it.
I would think so. I don't know much about Lonsdale Corporation, but I would think so, the way it's located. And the next step, also the next step for a corporation like that would be, so right now they're generating a lot of heat and it's done in a really nice way, but next, the ultimate district energy recovers heat from those who don't need it and have this interaction between them. And as far as I know, the Lonsdale Corporation is not doing that yet. But they have the capacity. What's nice is they could add these pieces to the puzzle and do it.
And I think when you talk about Lot 5 and the use, the demand of the energy that's down there, from where I come from, I work for a large institution on the North Shore, is that space utilization is the key to the energy consumption.
Yeah.
And whether or not you can keep that space going on a 24-hour basis or a shared basis, or it's evolving, and it's just like it's never vacant, it's always used, it's always ongoing, then that's really the success. It's a space utilization, and to maximize that, the energy, sort of the demand should never change. It should never, you know, and if you design it that way, then.
And that's such a good point.
Yeah.
Like, it's any building that is, unless your building has been designed with that in mind, one occupant or 500 occupant will probably use similar, the building in the end will probably use a similar amount of energy. It's going to vary a little bit, but you still have to turn the switch on in your building and get the ventilation going and get things going. And so if you're going to leave the door open, might as well have people use it.
Yeah, maximization.
Oh yeah.
Yeah.
Oh yeah. And that's something at BCIT we're trying to do. We're trying to say, on a Saturday, why in the, you know, we have 55 buildings and we have a class per building on a Saturday. So all the buildings are fully lit, ventilated.
Mm-hmm.
But the thing is, and again, I have to be careful to use this camera that I don't like,
You
but
can turn it off.
But it's people. Trying to change these things is so difficult. So difficult because people are used to certain things, and so when we brought up the idea of squeezing everyone in one building, and when this one will be full, we said let's move to a second building, and people started to say, well, I really like my classroom, you know, I've been using this classroom for 20 years, it's a blocked classroom, and you would be surprised.
Convenience.
Oh,
And I only want it on Thursdays.
There's a philosopher, I can't remember his name now, I think it's Schopenhauer or something like that. And so there's three main stages to change when you're trying to implement something, a good idea. The first stage is when you